over 2 up 4, over 3 up 9. Symmetric, looks good. This one starts at a positive 4, goes downward since the negative sign there, and everything looks good on that one, except 1, 2, and then down 4 should hit right there. It's can be hard to see it right on there. So that one looks excellent. Thank you, Liz. Then our next, flip it over. On this section, we have obviously something going on not only with adjusting vertically, but adjusting horizontally, because we have values inside the parentheses with the x. So similar to the absolute value function, we have a vertex form. Let's write at the bottom, make it really bold. So we can say y equals parentheses x minus h squared plus k. Write that out. Vertex then will always be hk. So this is kind of like point slope form or like vertex form of absolute value function. This is something you'll want to commit to your memory. Remember that h would be the opposite of whatever number you see in that parentheses, and the k is as is. So the vertex, I'll make sure everybody got it. The vertex for number 9 is positive 4, positive 3. So 4, 3. And then from there, since our lead coefficient is a positive 1, it opens up and it goes over 1 up 1, left 1 up 1, over 2 up 4, left 2 up 4. Ah! I jumped. And there you have your parabola.
We're not doing it now.
Let's see. We'll run out of space. So it's actually sufficient, technically, in a parabola to have 3 points, including the vertex, to create that parabola. 1 left, 1 right. That's sufficient. However, it helps create a better shape, a more accurate shape, the more points that you would add to that. So here I'd like to talk about the domain and the range. The domain, as you can see, it's important. Some people want to make it look like a U, and those arrows point vertically, but they actually continue to go outward, to the left and to the right, forever, which indicates that we have a domain of, yes, all real numbers. The domain for all parabolas is all real numbers. The range, though, since there is a value here, we're going to actually write that down. It's called a minimum. It's the lowest point in the graph. Since we have a minimum value, label that minimum. That indicates that the domain, or the range, is not all real numbers. Actually, the lowest number is 3, and then it goes on up. So we could say y is greater than or equal to 3. You'll find on Math Excel, it will say all real numbers greater than or equal to 3 for the range. Number 10. So this one, starting with the vertex for this one is positive 3, negative 3. So positive 3, negative 3. Lead coefficient is a positive 1, so that gives us the guidance to go ahead and go over 1, up 1, over 2, up 1, 2, 3, 4, and over 3. Well, looks like we've got enough there. So domain, again, is what? All real numbers. Every time we have a parabola or a quadratic, domain is all real numbers. Range is, who's got the range? We have a minimum. Again, this vertex is the lowest point on that graph, so it's a minimum. So the range is y is greater than or equal to -3. The next two, you can see that negative sign in front indicates that they should be opening downwards. So let's start by, for number 11, identify the vertex. Opposite of 3, so it's going to be -3, +4. So -3, 1, 2, 3, 4. And opening downwards. So over 1, down 1. Over 2, down 4. Domain being all real numbers. Range, this time, any guesses on what this point is called now? That it's the highest point on the graph? Excellent. Y is less than or equal to 4. That's the range. And our vertex is now called a maximum, since it's the highest point on the graph. Number 12, try that one on your own. You could check your work up on the board, and hopefully we can remember back from our absolute value days the axis of symmetry, sometimes known as the AOS, is x equals, and whatever the x value of the vertex is, that is actually the line of symmetry for the graph. So x equals +1 would be the AOS. Does that ring a bell from absolute values? Good. Last two. Going backwards. First, identify the vertex. So the vertex here is 0, -6. We have y equals parentheses x minus h squared plus k. So with this being our h and our k, we can substitute those in. So y equals x minus 0 squared minus 6. Since it's a -6, we can just write that as -6. Now a better way to write that, more efficiently, would just be to write y equals x squared minus 6. We don't need the -0 in the parentheses. That does nothing for us. Lastly, number 14, the vertex is 0, 3. So y equals It's going to be another x minus 0 squared, so we can just write x squared and then plus 3.